Hi, welcome back for page 3. Okay, number 9 is a converting metric units question. If you struggle with these, watch the MathWatch clip. Okay, so part A, change 385 centimetres to metres. So centimetres, there are 100 centimetres in a metre, so we would divide by 100 here. That gives 3.85 metres. 4.8 kilograms to grams. There are 1,000 grams in 1 kilogram, so there are 4,800 grams in 4.8 kilograms. 3,500 cubic centimetres to litres. Well, first off, a good fact to note is that 1 cubic centimetre is the same as 1 millilitre. So what we've got here are 3,500 millilitres. So it's that we're turning into litres, so that's 3.5 litres because there are 1,000 millilitres in a litre. Okay, 2 square metres to square centimetres. Now this is where it gets a little bit harder. If we think about 1 square metre, which is 1 metre by 1 metre, that is 100 centimetres by 100 centimetres. So if we worked out its area in centimetres, square centimetres, we would do 100 times 100 and get 10,000. So that is equal to 1 square metre. So this is where we stop using the 100 centimetres to 1 metre. It's not the same for square metres and square centimetres. It's a new relationship. So 2 square metres will be 20,000 square centimetres. Okay, and 4.5 cubic metres to cubic centimetres. And we should try and say cubic metres rather than metres cubed because that can lead to all sorts of confusion. Right, so just building on this a little bit more, I had a cube. Let's just go with 1 cubic metre. So imagine this cube was 1 metre by 1 metre by 1 metre. That would be a volume of 1 cubic metre. However, in centimetres, that's 100 by 100. We already know that's 10,000 times another 100. So that would give us 1,000,000. So that is 1,000,000 cubic centimetres. So 4.5 is 4.5 million, or 4,500,000. Okay, change 72 kilometres per hour into metres per second. So 72,000 metres, that's what kilometres is. So this is 72,000 metres per hour. So we've already changed into metres. Just need to convert the hours into seconds. For this, we need to first turn into minutes, perhaps. Oops. So what we're going to do there, if I want to convert hours into minutes, is divide by 60. So that's 1 hour, which is 60 minutes. That gives us 1,200 metres per 1 minute. And then to turn that into seconds, we need to divide by 60 again. Okay, which would give us 20. Okay. Number 11, I can't really do this on a computer because I need a ruler to do it, but I'll show you how to do it. We've got a diagram of a tree and a man, and this was an old exam question, not that old, a few years old, which caught a lot of people out. The man is of average height. Now first you need to know how high the average person is. And they gave you quite a lot of leeway when it came to marking this question. So I think they accepted anything between 1.5 metres and 2 metres. Now, 2 metres is a very tall man. So the average is about 1.8. Okay, so that's a good fact to know. I'm going to use that. The tree and the man are drawn to the same scale. Write down an estimate for the real height in metres of the man. So, yeah, there we go. So 1.8. One mark for knowing that. Find an estimate for the real height of the tree. So what we would do here is put our ruler up against the man. Obviously he's not 1.8 metres tall on a bit of paper. This would be, a matter of centimetres. We would measure how high that is. We would measure how high the tree is. And we would divide this by the height of the man. Work out how many men make up the tree, basically. Okay. Now, I suppose you could say you don't really need a ruler for this. You could, if let's say your finger was the same height as the width of your finger was the same height as the man, you could work out how many fingers make up the top of the tree, but it wouldn't be very accurate. So I'd recommend using a ruler. And I believe it was about 5.5. So 5.5 is what we get when we do that division. So I want to know what 5.5 lots of 1.8 are, and that would be 9.9 meters. Okay. Right. Number 12. Find the pressure exerted by a force of 900 newtons on an area of 60 square centimetres. So just recalling our pressure formula triangle. Pressure is force divided by area. Okay, so we've got a force of 900, we've got an area of 60. Okay, cross those off. 90 divided by 6, 15. Now, this is in newtons per square metre, so what I've not done yet, and I'm going to leave this in the video because it's good to see an error, is what I've not done yet is convert this to square metres. So 60 square centimetres, remember from earlier, 1 square metre is 10,000 square centimetres. So what I'm doing to get from this to this is dividing by 10,000. So if I do 60 divided by 10,000, what do I get? I get a fraction, or a very small number, 6 times 10 to the power of negative 3, so 0.006. Okay, and that's what we're going to go with. 900 divided by that gives me 150,000 newtons per square metre. Okay, and the last one on the page, Regan cycles 78 miles in 6 hours. His average speed for the first 30 miles is 15 miles per hour. Work out Regan's average speed for the last 48 miles. Okay, so what we're going to do on a question like this is first work out any missing bits of information we've got for each leg. So the first 30 miles, what we don't know, we know his distance, we know his speed, what we don't know is the time that took. Okay, so time taken for first 30 miles, excuse my handwriting, and we're going to use here our other formula triangle, compound units, speed equals distance divided by time. Okay, so we want a time, therefore we're going to do distance divided by speed. So 30 divided by 15, that gives us 2 hours, and that was in miles and that was in miles per hour, so we don't have to change any of the units. Now that means that the last 48 miles must have taken the remaining 4 hours. Okay, and we know that he must have covered, well, we know he's covered 48 miles in 4 hours. So 48 divided by 4 gives us 12 miles per hour. Okay, I'll cover the next page on the next video.